Okay, so we have already established the formula of the midpoint of a segment, or midpoint between 2 points in the previous video. We're also be able to, what they call this one, prove that formula so that there would be no more questions with regards to how the formula is really true. That formula is the same formula during high school years, and the same formula will be used here. Before we start, let me plot these points on this Cartesian plane so that we can visually see later on if our computed midpoints are approximately the same. So our point P is at 1 and 2. This is our point P. Our point Q is at 5, 2, 3, 3, 4, 5, and then -2, 1, 2. This is our point Q. And our point R is at -4, 1, 2, 3, 4. Here. This is our point R. So basically, if you're going to draw line segments between them, like this one here, and this one here, and this one here, then we can see later on that the midpoints are somewhere in between them, specifically bisecting the segments formed by the points. So let's find out if our midpoints later on, when plotted on this Cartesian plane after our computation, are approximately or accurately there. Let's start with the midpoint of P and Q. So this is equal to the half of the sum of their components. So you have 1/2. The components of first components of our P and Q is 1 plus 5. Okay, let me rewrite here the formula. Of course, you will have here 1/2. The components, the sum of the first components. Okay, and then 1/2 the sum of your second components. Okay, so just like that, first components, the second components. So let's try to solve for the midpoint. I'm just writing it in this notation, but this may not be true for all. Nevertheless, let me have that. 1/2. The first component of P is 1, and then plus the Q is 5, and then you have here 1/2. The second component is 2 and -2. So this is actually 1/2 of 6 and 1/2, sorry, this is plus, right, of 0. That would mean that the midpoint between P and Q is at 3 is 0. Finding that here, so here. So I hope that if my graph is appropriate, or approximately correct, so this is the midpoint of P and Q. So it's really on the x-axis. So basically, by visual representation, it's almost correct, and that's satisfying to have. So let's have the next one, P and R here. Let's find where the midpoint is. So for P, again, 1 and 2. For R is -4 and 0. So this is equal to 1/2. Your P is 1 and -4 plus -4. Then 1/2 for your 2 and 0. 2 plus 0. This is actually 1/2 of -3 and 1/2 of 2. So the midpoint is at -3/2 or -1.5 and 1. Let's find out if we're going to look at that here. So -3/2 somewhere here, right? -1 1/2 and 1. So my segment earlier is not accurate because, as you can see here, it doesn't really pass through the exact position of the point. So if I may erase this and redo that one, let's find out if we could really connect the midpoint. Yeah, somewhere like that. Okay, basically approximately correct now. Okay, so here I don't have the third one, but since we have plotted the segment there, let's also compute the midpoint between Q and R. So again, 1/2 of the sum of the components. Your Q is 5. That's 5 plus -4, and then 1/2. Your second component is -2 and 0. -2 plus 0. This is actually 1/2 of +1 and 1/2 of -2. This is now equal to 1/2 and -1. This should be the point in midpoint, specifically not just in between, but a midpoint of segment Q and R. So this is again 1/2, somewhere here 1/2, and -1. So this is the point, the midpoint of segment Q and R. So basically, if the graph is acceptable and approximately correct, so we have established all of these midpoints visually correct and using the formula intended here. So this is on the computing of a midpoint of a segment. Very important, because as we go later on, deeper on the some concepts on analytical approaches in modern geometry, specifically on normal lines, later on discuss or described as notations using vectors, we might be using some of these concepts. Thank you very much for watching.